All right, let's knock out day two. Here we go. Plan today. We're gonna knock out day two of Advent of Code. We read part. We read. We did part one. We're gonna do part two real quick. Let's go ahead and knock it out. All right, let's make a new file. Day two, part two. All right, let's go ahead and grab this. We'll go ahead and keep this kind of format. Um, day two, part. Day two, part two. Make a little function here. All right. So, and then reports, which is just a list. I don't know if Python supports that kind of types. I don't think so. I don't know. But yeah, here we go. Let's just jump right in, shall we? We're gonna read part two. We finished part one at the last stream. So now let's knock out part two real quick. Day three is already out. I'm behind. I just uploaded day one to YouTube. So that's cool. Trying to upload all of them. All right, so following along, the engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a React mounted module that lets the reactor safety systems tolerate a single bad level in what would otherwise be a safe port. It's like the bad level never happened. Oh, I think I know where they're going with this one. Okay. Now, the same rules apply as before, except if removing a single level from an unsafe report would make it safe, then the report instead counts as safe. Right. The same rules applies as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. Oh my goodness. This one seems a little challenging. Okay, let's see. More of the bug example reports are now safe. Right. Safe without removing any level. Okay. Unsafe. Safe without removing any unsafe regardless of which level is removed. Yeah, that's because it's because 12789 is has wait, what? 2 to 7 is wrong, but everything else is fine. Oh, no, 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 no. If you can't remove 7 doesn't work because if you remove 7 it's still wrong. Okay, I see what it's saying. Say if I remove the second level 3, so if we remove 3, yeah, 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 yeah. Okay. And then if we move 4, that's good because it removes a duplicate. Shoot, how do we do this in like a reasonable amount of time? how do we do this? Because one like the naive way of doing this is just remove every if it's unsafe, try to remove every single number one by one. And if any of that makes it if any time that becomes safe, then then um then that counts as a safe number. So there's a lot more safe. I mean, that counts as a safe report. I mean, how long I mean, is that too long? I don't think like the computer would have any issue calculating that. So let's just do it the naive way, shall we? It's not like there's like a million entries. So for what I'm gonna do is I'm actually just going to, you know what? I think I'm gonna delete this file and I'm just gonna do it all in the same file. Let's just delete that. And I'm gonna rename this to day one. It's just gonna have both parts. Why not? Just keep it simple. This is gonna be. Let's just rename this to day two, part one. Okay, and then we can just have. Oh, let's rename it with the IDE so it renames everything. Day two, part one. Okay, and then we have test cases here. Okay, sure. And then now there's a way we can reuse a bunch of code here from day one. Let's see if I can yoink them out. What I can reuse is I can make this into a function. So actually, so that's answer to number one. Okay, is there no way to get the data back? That's actually kind of scary. Uh, oh no, we can. Okay, that's fine. It's the same data set. I'm going to pull out a bunch of code into a function that is going to be important for this problem. And that's going to be the part that determines whether a report is legit. Okay, so let's make a function up here. We'll call it is report legit. Okay, it takes in a report. Sure. I'm just gonna copy all of these, all of that. Whoa, not all that. Oh yeah, yeah. Over here. And what we're gonna do is we're just going to return this. Return not broken rule. So this is basically gonna return a boolean. I don't know if this is how you do it. No, maybe it's like this. Yeah, 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 okay. And actually, we don't need even now that we have a function, we don't even need the state because we can just be like return true. I mean return false. Return false. Return false. Return true. Okay? We can assume all this works. And then in here, we just do if return if is report legit, total count plus equals 1, else total count. I mean, else do nothing basically. So we just do that. All right. And then these unit tests are like kind of, we can probably get rid of these unit tests. Yeah, let's just delete these for now. I am gonna rerun this just to make sure it prints out the right number. 341. Okay, yeah. All right. So the next thing to do is basically for part 2, we wanna have a very similar function here, except let's go ahead and print out day 2 part 2 report. We expect a much bigger number. And basically else report is not legit. Remove one entry from the report. Try again. So this is like a recursive function. So we could do this recursively now that I think about it. So what we can do is make a recursive function. Def day 2 retry check, and it takes a report, and basically it does this logic. Okay, before I do, whoa, desktop disappeared. Let's accidentally press the hide everything button. That's an annoying button. Okay, so yeah, okay, yeah, we can do this recursively. Let's see. So we're gonna basically change one entry in the report. So like report of I of 0, or pop it, or like, okay, report dot pop, and then we try again, retry. So we need like a retry function that takes in the report. Huh? How can we do this? I have a feeling that we can try something like this, and then recursive check. Right? So we have recursive check. For, and then it takes in 0. So this is like I. The base case is like if I is greater than, or we could do length of report break. or just return. Return false. We don't need these. And basically return true. Otherwise, pop out whatever's at I, and we do I plus equals, and then we do recursive check I plus 1. So, for example, if it's 0, we try it without popping, and then we pop the first element. So actually, we don't really want to return if I is equal to the length of the report because we haven't popped anything yet. Actually, let me see. Let me think. Just want to make sure I get the base case right here. If recursive check and then this is going to be our new total count. So if we are on, for example, we have 1, 2, 3. We got length 3 coming in. That means we already popped the last element because previously we were at length 2. We popped it. Okay, I think that's right. Okay. Um. Yeah. Okay. So this pops in place. I believe it doesn't return anything. Just gotta make sure that's true. Is there any documentation? Nothing. Usually when I hover over it, it gives me something. T buffer and turtle pop. How do I get the info? Info. Hover info. Nothing. Okay, I'll just Google if Python pops in place. Does Python pop in place? Oh yeah, yeah, yeah. Okay. Yeah, yeah. Okay. So that should be right. Should we just run this thing? Reports from outer scope. Where's the reports from outer scope? Is there reports over here? Oh, these? Oh, that's fine. That's fine. Oh, I got the same answer this time. Huh. No, it's definitely calling a different function. My recursive check is not working. Oh wait, I should return this. 394. Let me see. Let me see if we got him, boys. Let's see if we got him, boys. No, answer is too low. Huh. I was pretty sure that this would work. You know what? This should be a +1. This should be if I is greater than length of report. Oh wait, I see the issue. I see the issue. I see the issue. We are popping, but we need to regenerate. We need another parameter. Original report. Original report. New. So what this needs is the original report. All right. Then we have new report. So I need to pop. I need to not new report equals something like this. I don't think that's gonna work in Python. How do you make a copy of an array in Python? Hey Darmon, you must get paid a lot to do this. I don't get paid anything, brother. Not for doing advent of code anyway. I'm mostly doing it because my friends are doing it, and I'm like, dude, I'm not gonna fall behind. I can copy a Python with NumPy. Is that necessary? How's it going, Darmon? Welcome, welcome. I just need to make a shallow copy. Let's see, let's see, let's see. Dude. Uh looks like the way to copy an array is with NumPy. NumPy always. They should just make NumPy a part. Import NumPy as NP. Is that how you do it? Is that how I did the other time? Yeah. Recursive check. New report equals np dot copy report original. And then we're gonna do new report dot pop I. Oh, nice. Sub 20 hours. Yeah. For some reason, like my brain thinks the best way to solve this is with recursion. For some reason, let's just pass in the original report, and then let's just pass in the new report like that. So the final thing to do is what's wrong with this? Unresolved, unresolved. So because this is a NumPy array, I can't pop stuff. Pop element from index NumPy. Let me see. How do you remove a specific element from a NumPy array? And NumPy delete, which returns a new array with subarrays along an axis deleted. Some basic coding, college HTML, CS, some JavaScript. Nice. That's cool. That's cool. Some web dev. Some nice web dev. NumPy.delete. So the way to do this is new report equals NumPy.delete. New report at I. Okay. And so the thing is now, these are all NumPy arrays. So what I should do is I should make a NumPy array here instead. From array. Convert array into NumPy array. Python. How do you, so mp.array. It's mp.array. Okay. More of a designer UX. I see. I got you. Yeah. So the cool thing about Python is it has a really awesome math library called NumPy, and it's basically better than what the stuff the the array stuff that Python comes with. Like way better. But unfortunately it's pretty, because it's not built into the language, it's kind of annoying. But it is really cool. You can do all kinds of it's like data science uses it all the time to do their data science stuff. That's why they like Python. NumPy, so like data scientists are gonna be using NumPy all the time and some other libraries for visualization. Report is not legit. Remove one from the report. Try again. So now the new reports, original report. Okay. New report. We delete I and then we try again. And then we keep going until we reach the end of report. If I is greater than report, we can't keep going. Right. Because, yeah, that's an index out of bound exception. And it doesn't make sense to. But the problem is, you know what? I think what we got to do, what we're supposed to do is switch these two cases. So first check if it's legit. We do a check. And it doesn't hurt to do a check. And then we try. Then we do the failure case, which is if if the I is greater than the length, then we can't pop anything else. Otherwise, it's an index out of bound exception. Okay, that makes sense to me. mp.delete original report. So we pop one, we do the recursive check, we try again. Okay, cool. We get increment I. All right. For some reason, my brain thinks recursion is a good idea here, and it to me it makes sense. Let's see if it even gives me the right answer. I may just be full of it. No, it's not right. Okay, something's wrong. Something's wrong. Is report legit? I know this has to be right because day one is using it and it's right. We're returning recursive check. I need like a test case, so I'm gonna do test equals 1, 5. So it's gonna be like 9, 2, 3. So this should legit pass it. If I pass it into my part 2, so I'm just gonna print this out. If this doesn't print out 1, basically, should be 1, then there's something wrong with my algorithm. So test cases are always the way to go if you don't know what's going on. Okay, it is 1. This is surprising. Let me test the edge cases. So, like, that should also be 1. That's 0. Okay, the edge case is what's messed up. Got it, got it, got it. So this is why edge cases are important to test. And now that I know that it's an edge case, I realize that this needs to be original report, not report. Let's run this again. Now it's fixed, and now we get an answer of 404. That's funny. Okay, cool. Let's try this again. Let's put in the answer. Hopefully it's right this time. We got it, boys, dude. Recursion worked. It's amazing, dude. I feel super smart right now. And I feel smart for testing the edge cases like this and finding out what was wrong right away. It's like when you're in school, you really don't want to write unit tests, but then you're like, you know what? Unit tests are like are a blessing from the Lord. Anyways, or at least they're writing some sort of test. They don't have to be unit tests, but hell yeah, dude, we got it. We freaking got it. So just to recap on what I did for the YouTube video, um, I basically I chunked out this part of the code that's like that came from the part 1 of the of day 2, which is just checked if a report is legit. I made sure this works. And so I just assume this works because it has nothing to do with part 2. Well, we could abstract this away in part 2. And so in part 2, the because you're allowed to remove, right, let me go back to part 2 in AOC. Because you're allowed to remove any one level, I decided to take a recursive approach to this and then pass it back into my isReportLegit function. So you could have done this with the loop, sure, why not? But it just made sense for me to do this recursively in the simplest as the simplest way to do it. And that means all I had to do is this recursive check once. And if that passes, we can increment the total count. And so what this recursive check does is it does the original algorithm. It calls the original algorithm from day 1 that just checks that the report is legit given the current report, given any report. So like it just checks any row, any report is what they say, what it's called in the problem, and it just checks if it's legit or not. And it doesn't care about anything else. So what I did was I popped out one element each time, and then I reran it through that algorithm that validates a report. And then I kept trying that until I popped every single element in the report to see if it is possible to remove an element to make it legit. Of course, if it's legit right away, we have a base case to exit early from the recursive function. Also, another base case, if it's at the end of the report, if there's no more elements to remove to possibly try, so false. We can't remove an element to make it legit. And then otherwise, the recursive case is we delete an element from we pop one element from the array, and then we pass it back into the recursive function that reruns all of this. And I'm using NumPy just because it's easy to delete elements and copy them. So in NumPy, the delete function is not in memory like the pop function is in Python. What that means is the pop function in Python mutates the original array. I didn't want that. I wanted it to return a new array because I don't want the original report to change. Because this is important, we always need to know in the recursive function what the original report is before we pop anything out, because Otherwise, we end up with a continually smaller and smaller report every time we run the recursive function, which would mess things up a lot. So yeah, so that's it. Day 2 completed. This is a simul shift. I don't know why I'm snapping my fingers. Anyways, cheers, my friends. But anyways, that's just for the YouTube video. I mean, I could go on to day 3, which might be interesting. Maybe I can go on to day 3 or at least start it. I guess I can start it. We can start with part 1. I'm gonna head and I'm gonna um I'm gonna before I start day 3, I'm going to like show off my solution to the bros in the Discord. Uh yeah, why not? After all, why shouldn't I? Whoops, my replay. Um Let me see if they recorded everything also for the YouTube vids. YouTube vids. Yeah, okay. Yeah, that was a lot faster. Everyone said this problem was really hard, which is what freaked me out. Freaked me out because everyone said, yeah, it freaked me out because everyone said day 2, part 2 was really hard, and then I did it. And then it was like, you know what? I'm a genius for some reason. I don't know. Recursively, it made a lot of sense. It was really clean. The solution is really clean recursively. Like, boom, it just separated it into a few functions, and then we got the answer. Uh, which is pretty amazing. Okay. So yeah, let me just copy all this. Posting this in Discord. Advent solutions of Advent. Give me a moment. Give me one momento. I gotta show off. Pretty proud of day 2 solution. Just finished it. Solved it nicely. Solved part 2 nicely with recursion. Basically, popped an element from the list and did a recursive check to see if the list is legit. See if the report is legit again. All right, let's go on now for day 3. Okay, so let's make a new file. Call it day 3. New Python file. Let's go on and yeah, let's see. Um, yeah. Advent of code. Number 3, our computers are having issues. Okay, so first of all, the title is Mull It Over, Day 3. So I have no idea if we have any chief historians in stock. You're welcome to check the warehouse, though, says my leaf luster shopkeeper at the North Pole Toboggan rental shop. The historians head out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? The computer appears to be trying to run a program, but its memory, your puzzle input, is corrupt. Did All the instructions have been jumbled up. It seems like the goal of the program is just to multiply some numbers. It does that with instructions like mul xy, where x and y one are each 1 to 3 digit numbers. For instance, mul 44 46 multiplies 44 by 46 to get a result 2024. Similarly, multiply 1, 2, 3, 4. 4 would multiply 1, 2, 3 by 4. However, because the program's memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of a mul instruction sequence, like mul 4 times up, mul 69, or mul do nothing. For example, consider the following section of corrupted memory: x mul 24, mul 37, do not mul 55, mul 36, 64, then mul 1118, mul. Whoa, okay, that's a lot of stuff. Only the 4 highlighted sections are real mul instructions. Adding up the result of each instruction produces 161. Times 4 minus 9. Scan the corrupted memory for uncorrupted mul instructions. What do you get if you add up all the results of the multiplications? So, okay, let me download the puzzle input. This looks like string parsing. This looks like string parsing. Oops. What did I save it as? Yeah, day3.txt. Okay. Oh, dear goodness. This is a string parsing extravaganza. So first, I'm just gonna copy. I'm just gonna copy this part to get back the problem set. And let's just start simple. Let's just print out the problem set just to make sure there's no artifacts when you read the file. Oh, day 3. Okay, it looks fine. If I look into it, there is a new line at the end, which is annoying. Whatever, whatevs. We'll deal with that. Yeah, let me get some water real quick. Actually, I'll be right back. I'm parched. Be right back. All right, we got water. We got hydration. We got hydration. Yeah. So this problem seems like regex. So if you know regex, you're happy. You're a happy camper. Otherwise, otherwise, we're not happy campers. Everything is a multiply command, so that seems simple. Um, let's just do some stream parsing, shall we? Let's see what we can do. So, what I'm basically gonna do is I'm gonna loop through every single character, loop through every single character. We're gonna have a result. Let me see. How about parse string equals an empty string, and then we're gonna do for c in problem set, and basically we're gonna check if we hit an n, and then if we hit an n, we're gonna check if we hit a u, And then if we hit a U, we're gonna check if it hit no. So actually, we don't even need to do that much. We can just be like, uh, we could just be like, check if upcoming substring is starts with mole. So I imagine that there is a, you know what? We should do a for range for I in range of problem set. What's wrong with this? Got string instead? We could split it, maybe. Oh, I'm sorry. Forgot we need in Python. We need the length. Okay, there we go. And then check if the upcoming string starts with mole. So if problem set of I onwards starts with mole, then we're gooch. Then we're going to append the next characters until we hit a closing brace. Okay, a closing. So we're going to foresee in problem set of I parse string dot append, or we could just say plus equals C. If C equals closing parenthesis, we don't need these. I keep adding parentheses, but we don't need them. And we can just say break like that. And then what I'm going to do is I'm just going to print out parse string, and we're going to see if it gives us what we're looking for. Okay, so we can do all this. Try it out. And it looks like we get something kind of close to what we want. But not quite. So this keeps going. Oh, I kind of see what's going on. Um, hmm. Actually, we got rid of all the with junk characters. There's new lines in there. Are there new lines in here? There are. There's six. So I think we want to strip new lines. Strip new lines. Python. I know we can just do that strip. Maybe just dot strip is what we want to do, or we just do it here. Does this strip more than new lines? Strip might remove too much. Let's do replace n with nothing. So that'll get rid of it. I wonder why it keeps. Oh, this break is happening too soon. Just put it back here. Okay, let's rerun this. Control F5 for rerun. Okay, cool. Okay, now we got something. Now we got something, and it looks like it's almost correct. There's still some artifacts. Still some artifacts. These are really long lines. Wow. Okay. And I think I'm also gonna do something like um this. Then we're going to add a special character. Well, before we do that, I'm gonna add a special character, or add a. We'll just add a new line. Add a new line. So yeah, let's add a new line here. Parse string plus equals a new line, and this is just gonna make it easier to to do the calculations and see what's wrong. Okay, so we can see what's some wrong easily now with some of these, where 417 and 109. Let me see what's going on over there. And I'm just gonna look up 417, comma 109 and see what's going on over here. So, okay, so there's weird stuff going on. So I'm assuming this is invalid. Let me look at what the problem says again. So that's invalid. Okay. Cool. So basically we need to do like an is